Hi students, this is a reteaching for your Saturday or Friday. You will decide assessment, same program that you had for Monday. As you know that the results were not satisfactory. So I want you to review the previous sheets in addition to that one. So we have seats in a theater. We have men represent 25%, women 0.4, and the rest are kids. So it's a total probability because they said the rest. So we don't have common. So in this case here, 1/5 of the man is H, on, because it's from French back. Already seen the film. Seen instead of S it's V. Ils ont vu. This is in French. So complement, not seen, and man is 0.8, to fill the table. And woman, 30%. So P of seen knowing women 30, not seen knowing women there is 0.7. So you do the product. And for the kids, they didn't give me here. So we need to calculate it. We're going to see what they're going to give so that I can find this one here. So I'm going to write P of V knowing E. I don't have for kids. P of non-V knowing E. And the intersection, it will be 0.35 times this P of V knowing E and 0.35 P of non-V knowing E. The first question, what's the definition V intersecting H? So it's the V intersection is H. It's the person which is a man and who saw the film. Okay, they want P of V knowing H is 0.2 and P of V intersecting H is 0.05. Now they said that P of V is 0.4. What does it mean P of V is 0.4? We all know, because it's a total probability, P of V is nothing else than P of V intersecting H plus P of V intersecting F plus P of V intersecting E. Okay, since P of V is 0.4, P of V intersecting H is 0.05, and P of V intersecting F is 0.12. So if you want to find P of V intersecting E, it will be 0.4 minus 0.05. You can see it here. And P of V intersecting F, which is minus 0.12. So we have now P of V intersecting E. Since the question here they want determine the probability that the interview spectator, a kid who already seen, knowing that he is a kid, enfant yani kid, and he saw, so I want P of V knowing E. Since now I found P of V intersecting E, which is 0.23, here this is 0.23, so P of V knowing E will be 0.23 divided by 0.35, and I have this answer. Now they said deduce the probability that the interview spectator who had already seen, knowing he saw the film, knowing he is knowing that he is a kid, find the probability that the interview spectator who had already seen this movie before is a kid, not knowing. I cannot put two known. Is a kid. This is wrong here. Okay. So I want to predict that the interview spectator who had already seen, knowing that he saw. So as you can see, this is the vice versa. You did a big mistake here in your Monday's assessment. When I want to have the inverse, so I put the property, don't forget. So P of E intersecting V over P of knowing V. E intersecting V, we already have it. We calculate it up at 0.23 over P of V, which is 0.4, and you have this answer. Now, two spectators were interviewed with replacement. So with replacement, it means independent. So we can pick the person more than one time. Find the probability that one saw the film only. So I want one saw and one didn't. Since it's independent, I do P of the first times P of the second. Don't forget that the order here is important. So if I write here and I stop, it means I want the probability that the first one I want to pick didn't he saw the film, the second didn't see. But what about vice versa? So that's why when you have total probability and the events are independent, you must put all order. So this is 2 times P of seen is 0.4 is given before, not seen 0.6, the complement, 1 minus 0.4 is 0.6, and you get this one. Now I have 3 spectators. Find with replacement, I can pick the one more than one time. Find the probability that only 2 saw the film only. I want 2 saw and 1 didn't. You can write it this form or that form or this form. So how many choices I have? I have 3 of 2 saw and 1 didn't see. So 0.4, 0.4 times 0.6, and the number you multiply it by 3. Now we have 1,000 spectators, and we want to pick simultaneously. Simultaneously, it's dependent. It means it's not anymore P of the first times P of the second, and take order into consideration. What is the probability of interviewing 3 women? 3 women, I have women 0.4. So 0.4 times 1,000 is 400. I want 3 women. 3 out of 400 over 3 out of 1,000, so which is 0.064. Okay. Now in the second one, what I want, what is the probability of interviewing 3 persons who has never seen this movie before, knowing they are men, not seen, knowing they are men, not seen, knowing that are men. I have it 0.8. So I have 1,000. 1,000 times 0.8 is 800. So I want the 3 out of 800 over 3 out of 1,000. So the answer will be 0.51. Number 2, an urn contains 4 white balls, 5 red and 3 green. So as a total I have 12. We select randomly 3 from the urn without replacement. So either combination or arrangement depend on order. Calculate the probability of selecting 3 balls of the same color. So either 3 are white or 3 are red, as you can see here, or 3 are green, over total 3 out of 12. So this is dependent, not independent. I'm not going to draw the ball, I'm going to return it back. Prove that the probability of selecting at least 1 green ball and at least 1 red. I want minimum 1 green in the draw and 1 plus 1 red. So among the selected ball is 21 over 44. You want green with red. At least either the third one can be green or the third one can be red, right? Or it can be white. So do you have other alternative? I want always green and red, minimum 1 time. So I don't have other choices. I want minimum 1 green and 1 red, minimum 1 green and 1 red, minimum 1 green and red, and the other three it can be either green, red, or white. So here 2 green and 1 red. So 2 green, it means 2 out of 3 and 1 out of 5. Here I want 2 red and 1 green, 2 red and 1 green, 2 out of 5 and 1 out of 3. Okay, here 1 green, 1 white, so 1 out of 4, 1 out of 5, 1 out of 3 over total, so you have 21 over 44. This game ran as follows. The player selects at random and simultaneously 2 balls from the urn U. Okay, so I have, don't forget, in urn U, 4 white, 5 green, 5 red and 3 green. I want to select 2. If at most one of the 2 selected ball is green, at most, maximum, you may have no green or 1 green and 1 not green. If you have at maximum, you get 5,000. So if at most one of the 2 selected ball is green, either 0 green, green bar, or 1 green and 1 non-green, you get 5,000, and the game ends. If the 2 selected balls are both green, so the rest, if both are green, you get 8,000. After that, the player selects randomly and simultaneously. Okay, but here the 2 balls that you're going to get, they are kept outside the urn. You're not going to take it. If two selects are both green, they are kept outside the urn, you and the player received 8,000. After that, the player selected randomly and simultaneously 2 balls from the urn from the remaining 10 balls in the urn. Suppose it was 10, 12, now it's 10. So instead of having 5 white, 5 red, and 3 green, now I have, because I have draw before 2 green, I'm going to keep it out. I have 4 white, 5 green, 5 red, and 1 green. So I have 10. If these two selected balls are of the same color, so now if I want to draw two same color, we get 12,000 and the game ends. Otherwise, the player received, if not same color, we get what? 2,000 and the game ends. So the first question, what's P of 5,000? This is very simple. P of 5,000, I want to get one green, one not green. So one green, one not green, I have 1 out of 3, and not green 1 out of 9. Or 2 green, 2 out of 3 over total 2 out of 12, so 21 over 22. P of 20,000, this is the 20,000, it's 8,000. I want to move from here till up. So first of all, I want to pick P of green times green. I will keep the balls independent here. So I have another draw. What is the other draw? I want to pick two of the same color, but when I want to pick two of the same color, I don't have any more 12 balls. I have only 10. And this is order not import. So here, as you can see, it's a combination. So you must be careful of these because you made a lot of mistake in the previous assessment. So I want two green, two green. I have 3 green here. So 2 out of 3 over 2 out of 12. Then I keep the 2. I want to pick two same color. Either 2 are white or 2 are red. So 2 out of 4 plus 2 out of 5 over 2 out of 10. Why it's independent? I want to draw first of all from the first urn. Then I will keep these two. I will draw another time from the second, another time from the same urn. Okay, so I have to draw each one alone. I do the order of the first one, then the order of the second one. If you do it, you're going to get 8 over 495. Deduce P of 10,000. I have this one, the answer of this one. I have the answer of this one. Remains what? The answer of this one. Either I do it two ways. Either I say it's 1 minus P of 5,000 minus P of 20,000, which is this one, or I repeat it again. So it will be P of green, green times P of two different colors. But if I want to do different colors, I want to take here one white, one red, meaning 1 out of 4, 1 out of 5, plus 1 out of 4, 1 out of 1, plus 1 out of 5, 1 out of 1 over 2 out of 10. Instead of doing all of that, because this is the 100%, I have the P of 5,000, I have the P of 20,000, remains only what? One choice. So I do it 1 minus these two. Another problem number 3. We have a competition. Each question is written on a separate card and all these cards are placed in this bag. We have 60% are math. So P of math is 60% of the cards. And the general knowledge, here you can have general knowledge, is the rest. So you can see it here. I have math general knowledge. This is a 3 table. See, it's correct. Calculate first of all. Let me continue. A student who is consistent. A card from a bag. Okay, is going to pick one. I have these choices. Calculate the probability of P of M, P of G. I have it here in the table. We are given the information which may use to answer the remaining question. The probability that the student answer correctly, knowing that he is a math, knowing math is 2 over 3, so complement is 1 over 3. The probability that the student answer correctly, knowing that general knowledge, correctly knowing general, or the complement of it, 0.75, this will be 0.25 if you do. So here you do the product, it's 1. Find the probability of M intersecting C. M intersecting C is 2 over 5 from the table. I want P of C, it will be, because total probability, P of C intersecting M plus P of C intersecting G, which is 0.7. So P of correct is 0.7. Part 3. The competition rules as are as follows. Each contestant draws at first one question. If the question was correct, he scored 10 points and does not draw a second question. If the first question was incorrect, he answered wrong, then the question is put in the bag. So he's going to return it back. So it's independent. So, and then he draw a question. If the answer is correct, he scored 5 points. If not, if it was wrong, he returned it also back. So here I have 3 products to get here. So in the third time, if it's correct, he get 2 points. If again for the third time it's wrong, he will lose 5 points. Find P of 10. P of 10 to draw a correct answer. We know it from before. Correct answer, we did it in part 2, 0.7. Here I know 0.7. Then you want P of 5. P of 5 because independent. So P of non-correct in the first one times P of correct because he returned it back. So it's independent. Okay, he returned it back like the problem we did up. So it's 0.7. If 0.7 was correct, incorrect will be 0.3. Here must be 0.3 and here 0.7. Doesn't matter, 0.21. Now we want gaining a score. Gaining a score either 5 or 10 or 2. Remains to find 2. To find 2, it's P of non-C. Then we return it back P of non-C another time. Then P of C. You can see non-C independent because I'm returning it back. So P of non-C 0.3, non-C 0.3, P of correct 0.7. This is the answer. I want the probability to gain a score. To gain a score is P of 10 plus P of 5 plus P of 2. If you make the sum, it will be 0.973. Loss, it will be everything minus this one. Or you do it P of non-C, which is 0.3 times P of non-C 0.3 times P of non-C, P non-C, P non-C, P non-C 0.3, it will be 0.027, or you do 1 minus the gain. In the same problem, now we had how many questions? 80. So we said that P of C was 0.7, so it means we have 56 correct question, 56 correct, and we have a 25 wrong. Okay. The competition rule as follows. Each contestant draw at first one question. If the question is correct, like up, we get 10 points. If it doesn't, he draw another question. But if the contestant does not answer the first question, then the question is put back in the bag, after which he draw a question. If the answer is correct, he get 5. If not, he will draw another question. If if his answer is correct, okay, he draw a question. If the answer is correct, he score 5 points. If not, he withdraw another question. If his answer is correct, he get 2 points. If not, he is penalized. But here they didn't tell us between here and here they return back. He returned it back only in the second one. In the third one here, he doesn't return it back. So here it is not. It's either arrangement or combination. But because order is important, here it's arrangement. Okay? Because they didn't say. They said they returned it back in the first one. Okay, here it's put back in the first one, but not here. Okay, so find P of 10 like we did up. P of 10 is P of correct 0.7. Now I want P of 5 like we did, honey. It's here, it's P of the first times P of the second. Because why? Because it's independent. So P of 5 is PC bar, then directly P of C. So 0.3 times 0.7, 0.21. Now I want P of 2. So the first one is P of C bar. Then he's going to draw C bar, then C. But here, as I said, arrangement, because he's not going to return it back. So it's arrangement. I want one not correct, but order important. One not correct. Not correct is 24. One correct, 1 out of 56 over total. You get this answer. Then they ask us about P of winning. So this is P of 5. They want P of unique, so that's why I need to do P of 2 before. P of unique, it will be this one plus that one plus that one, and P of loss 1 minus all. Or you can say P of non-C, which is 0.3, times arrangement here. I have 2 loss, you need 2 out of 24 over 2 out of 80, and if you do it on calculator, you're going to get the same answer, 0.026. But suppose the question was, if you get a correct, you get 10. If not correct, you keep it back and you continue. So here it will be for this one. In that case, if all not returned, what is the probability of getting 5? So here it will be arrangement of, because it's dependent, you will do one not correct, which is 1 out of 24, and one correct, 1 out of 56, over total 2 out of 80. And for the last one, if you want, for example, to get 2, you do, I want not correct, but see order important, not correct, not correct, correct. So you do 2 out of 24, 1 out of 56, over 3 out of 80. And for the last one, you're going to get arrangement 3 not correct, 3 out of 24 over 3 out of 80. So be careful, read well the question, and always I advise you to put this diagram. Another problem, secondary 3 students at BHB are distributed in 2 groups, American and Lebanese, where their total number is 64. Total is 64. Such that 26 are in the American. So let me put a table, because they are saying American, Lebanese, and girls, boys. So I'm going to put girls, boys, American, Lebanese. This will help us a lot. So I have 64. I have 18 girls in the Lebanese cycle, as you can see, and 14 boys in the American. So because here you have 18 and 14, and total number of American, they said here, is 26. So you can get this one. Once you have this one, you can get this one. Once you have this one, you can get that one. And if you have these two, you can get these, and the last one here. So find the probability of picking a girl. Girl, how many girls I have? I have a total of 30. So it's 1 out of 30 over the total number, because I don't have knowing. Find the probability of picking from the set of Lebanese. I want from the set of Lebanese a boy. So knowing Lebanese. So now the universe is only Lebanese. So 1 out of 38, as you can see down. I wanted a boy, so it's 1 out of 20 over. Please don't do it 1 over 20. Don't put this one here over, nor here. It's a combination. So 20 over 38. We need to pick 5 students from for a basketball game. Find probably to pick 2 boys from the Lebanese cycle. I want 2 boys from the Lebanese. So I want 2 boys from the Lebanese. In the Lebanese, I have a 20. So 2 out of 20. And the last 3 will be from either here or here or here. From these 3. Or 64 minus 20 from the rest. So you're going to get 0.33. In this part, we need to pick 2 students, such that one from the Lebanese cycle and one from the American. Guys, listen. In the Monday test, you made a lot of mistakes concerning this problem. I want to pick one from the American and one from the Lebanese. This is independent. One from that set, this set alone, and that set alone. So this is independent. P of the first times P of the second. Find the probability of picking 2 girls. It means picking a girl from the American, knowing from American, and a girl knowing Lebanese. I don't do it as you did it in the previous Monday test. We don't do it all overall. No, each one alone, each probability alone, independent. So here to pick a girl is 1 out of 12 over 1 out of 26, because from set A, I have in set A how many total? 26. And I want a girl knowing Lebanese. Knowing Lebanese total is 38, 1 out of 38. And I wanted a girl 1 out of 80. Find the probability of picking one girl only. One girl, and I want girl from American, boy from Lebanese, or boy from American and girl from Lebanese. So independent, same story. Girl from American, it's 1 out of 12 over 1 out of 26. Boy from Lebanese, 1 out of 20 over 1 out of 38. Boy from American, 1 out of 14 over 1 out of 26. Girl from Lebanese, 1 out of 18 over 1 out of 38, and you have that answer. So please, when you have two sets and I want to pick from each set, so it's independent. Don't repeat your mistake. Number 5, stores selling shirts and pants of two colors, black, white. You have the table given. Find the probability for a customer to buy two pants. So if you want to put the total, you add here, shirt and pants, whatever. Find the probability for a customer to buy two pants. I want two pants, so it's 2 out of 25 over total because I don't have knowing. Find the probability for a customer to buy one black pant and one shirt. One black pant, so I have 1 out of 25. One shirt, they didn't mention the color, so it's 1 over one shirt, sorry. The total number of shirt is what? 125. So I want one shirt, 1 out of 125 over a total, which is for all 2 out of 80. Another customer want to buy one pant and one shirt. Like we did, I want one pant and one shirt. So it's independent. I don't do it like I did here, like this one. So it's independent. This is alone. And this set is, I have two sub-universe, and this set is alone. What is the probability to buy same color? To buy same color in a black shirt, knowing shirt, and the black knowing pants, or white knowing shirt times white knowing pants. Black knowing shirt, so 1 out of 50 over 1 out of 25. Black knowing pants, 1 out of 25 over 1 out of 55. You don't do it over. I'm repeating it always. So this is combination. In the test you put it. By the way, never a probability. Don't you ever write a probability whose number exceeding 1 or minus 1. Probability is always 0 point. It cannot go more. When probability we say it's 1, it's 100%. We cannot go more. And white knowing shirt, so 1 out of 1 out of 75 over 1 out of 25. White knowing pants, 1 out of 30 over 1 out of 55. You have this answer. Opposite color, it means black knowing shirt than white knowing pants, or white knowing pants, shirt, sorry, and black knowing pants. You do it the same thing and you get the answer. D. So D, the last one. The price is given in the following table. The price of these. Black shirt costs 50,000, whatever. A client want to select one shirt and one pants. Find all possible payment. He want to select one from here and one from here. So he's going to pay either 50,000, one black and one black pants, or 50 with 85, or white with white shirts and black pants, and white shirts and white pants. If he had the choice to pick any, not one shirt and one pant, he can pick two black shirt, or two black white, or two black pants, or two black white, or one black shirt, one white shirt, one black pant, and one white pant, in addition to these. So we have more than these. But they said they want one shirt and one pant, so that's why I have only 4 choices. This with this one, that with that one, and vice versa here. Find the probability of each payment. What's 130,000? 130,000 is going to pick one black shirt from the shirt, knowing shirt. Okay? So how many we have? 1 out of 50 over 1 out of 25. And he wants 80,000 here, refer to one black pant. How many black pant here I have? 1 out of 25 over total, because independent, as we said, we have this one. For 135,000, he wants 50 with 85, one black shirt from this shirt set, 1 out of 50 over 1 out of 25. Now I want white pants. So from the set of pants, 1 out of 30 over total 1 out of 55, we have this answer. And for the second one, the same story here. I have 60 and 80. So 1 out of 75 over 1 out of 25, and 80,000 is 1 out of 25 over 1 out of 55. You can see it here. And the last one, 60 and 85. So here, this one and that one. So 1 out of 75 over 1 out of 25 times 1 out of 30 over 1 out of 55, and you have this answer. The sum here is 100%, must be 1. So please, when it's independent, like this one, I want to pick one from here, one from here. I do each one alone. Okay. So I want you to listen and to repeat. We're going to meet either on Friday or Saturday. I will check with you in a while. And this time, please, I want you all to participate. So maybe I will do it on Friday. So let us assign Friday noon. Friday noon at 12. You're going to have your assessment. Okay, I will check with you now.